Okay, so here we are in our mechanical room, and I wanted to give you a closer look at our heat pump that I was talking about earlier. So it captures that 55-degree temperature from the Earth. The Earth maintains about 55 degrees Fahrenheit throughout the year. And there's about 3,000 feet of coiled tubing that's buried under our front lawn that pick up that 55-degree temperature, and they circulate it through into the heat pump, and they preheat the heat transfer fluid that gets sent to our radiant floor heating system. So we're taking the heat from the earth, from underground, and putting it under our feet inside the building to heat the building. And though 55 degrees doesn't sound super warm, it's a lot warmer than the air temperature in the wintertime. And because it's repeatedly circulating through and collecting that heat from the earth, it really does quite a bit to enhance the ability of the heat pump to heat the system. So like I said, there's a metric called coefficient of performance. A typical furnace, like a combustion appliance, a gas furnace or an oil furnace, usually for every unit of energy you put into it, so every BTU you put into it, you get about 0.8 BTUs out, or 0.9 if you have a really efficient furnace. But with a heat pump, for every BTU energy that you put into it, you can get up to 3 or 3.5 out. So that's pretty remarkable. So for every unit of energy that you're putting into it, you're actually getting more energy out than you put in, because it's collecting that energy from the earth, and then the heat pump itself is also an extremely efficient appliance. And it essentially works like the reverse of an air conditioner. So you ever touch the back of a window AC unit, it's really hot. That's the same process that's happening in here, and that heat is what you capture and send into the building. And that refrigeration cycle or evaporation condensation cycle with these refrigerant gases is a highly efficient process. So there's also something called an air source heat pump, which does the same thing that this does, except instead of collecting heat from the earth, it collects heat from the air, or it collects cold temperatures from the air, depending on what you want to do. And they both work in reverse. So you can actually do cooling with this if you want to, and you can do cooling with an air source heat pump as well. So those are much more common for residential use, and in the Northwest, because we don't have super harsh winters, it's a really effective heating source and super efficient as well. So if you're looking at replacing your furnace or your heating system in your house, I highly recommend you check out air source heat pumps. And if you can afford a ground source heat pump, that's even better. It has a higher capital cost at the outset, but you'll save a lot more over the course of the system. So yeah, that's a basic summary of how our heating system works.